So hopefully you've been able to watch the videos about Hubble's law, as we'll now go through the school notes to fill in the blanks and to explain what the notes are actually telling us. So Hubble's law was discovered by Edwin Hubble. He studied the redshift of a number of galaxies to determine their relative speed to Earth. He discovered the farthest away galaxy is faster it was moving away from Earth. He observed this for 24 bright stars, and more recent analysis over thousands of stars, we can produce the graph below. On the y-axis, we have velocity, and on the x-axis, distance. The black dots are the stars and the speed they're moving at relative to their distance from Earth. This unit here for distance is the parsec, megaparsec. It's not one that comes up that often, it's just in this graph, it's just a unit of distance. If you think of the equation of a straight line, y equals mx plus c, y is the y-axis, x is the x-axis, and m is the gradient. We can replace these quantities with velocity equals Hubble's constant times distance. Hubble's constant being the gradient of the line. What we can derive, therefore, is that the speed against distance from the Earth produces a best fit straight line that passes through the origin. This shows that the relative velocity is directly proportional to the distance from the Earth. So the further away you are, the faster your velocity is. The red line, or the gradient, is known as Hubble's constant and has a value of 2.3 times 10 to the minus 18 meters per second. V equals HO, Hubble's constant, times D. So the constant is known as Hubble's constant, HO, and it is a value of 2.3 times 10 to the minus 18. This is a formula which you need to use, and it's given to you in the formula sheet. How is this asked to you in an exam, or how would you work through questions? Let's have a look at an example. An observatory collects information from a distant star, which indicates a redshift has taken place. The wavelength of the light from the source is 656 nanometers, while the wavelength observed is 676. So the first thing you have to do is label the two wavelengths, observed wavelength and rest wavelength. If you get these the wrong way around, you will get 0 marks for the question. The first mark available would come from writing down the formula. Z equals observed wavelength subtract rest divided by rest. Second mark available would come from substituting the numbers in correctly. 676 take away 656 divided by 656. This allows you to calculate the redshift, 0.03048. Now, the question asks us to work out the velocity of the star. Velocity is equal to the redshift multiplied by the constant of speed of light. So the velocity of the star, given us the answer to part A, is 9.15 times 10 to the 6 meters per second. If the velocity of a distant galaxy is 1.2 times 10 to the 7 meters per second, show the approximate distance to this galaxy is 5.2 times 10 to the 24 meters. So we have velocity, we know Hubble's constant. Using the graph above, we can work out the distance that this galaxy is away from Earth. Rearrange our formula, V equals H naught multiplied by D. Therefore, D equals V divided by Hubble's constant, which tells us that the distance is 5.2 times 10 to the 24 meters. Also, just below here in the brackets, I've included how you work out a light year. There is a separate video and picture of this in the Firefly blog. A light year just being the distance light travels in a year. So we have the final answer for part B. We have the final answer for part A. Hubble's law is just a simple formula. V equals Hubble's law times distance. You can theoretically work out the age of the universe through Hubble's law. If you rearrange it, time equals distance divided by speed. We know that Hubble's law is 1 over h naught. If you rearrange it, equals d over v. So we could say therefore that time equals 1 over Hubble's constant. So to calculate the age of the universe, given the estimate for Hubble's constant is 2.3 times 10 to the minus 18, if we plug the numbers in, time equals 1 over that, which is 4.35 times 10 to the 17 seconds. Now here, this is like the question I showed in the other video. They want to know how many years this is. So this is just a changing of units. You're turning 4.35 times 10 to the 17 seconds into years. So if I said to you 30 seconds is how many minutes, you would do 30 divided by 60. So 4.35 times 10 to the 17 is how many seconds in a year. You have to multiply through to give you 1.37843182 times 10 to the 10, which can be rounded up to 1.4 times 10 to the 10. So Hubble's law suggests that galaxies that are farther away are moving away faster than galaxies that are close to us. This suggests the universe is expanding. This is proof, or said to be proof, of the Big Bang theory. Tomorrow we'll go on to the next topic, which will finish the booklet. The last hour on Friday will be revision, and over the weekend we'll be catching up on any questions missed.